Hey, hi everyone. Good morning.
Good morning.
Yes, good morning. Uh, so what was the last topic that we have discussed? Yes, what did we discuss in the last session?
Mathematical operations are numbers.
Okay, excellent. Give me a minute. I'll just share my screen and then we'll start. Yeah. So it was day 6. All right, we have seen this one, no? Uh, Mathematical operations on NumPy. Now, in this session, we are going to uh, yes, we are going to see uh, yes, we are going to compare the computation times of the list and numpy. So if you remember in the beginning, I have told you that numpy array is 50 times faster than your list, right? So here we are just interested to compare how it is possible practically, right? So it's an additional part, but I'll just cover because you should remember that because uh, if somebody asks you in the interview, you should be able to tackle this question at that time, right? So I'm going to compare computation times in NumPy and then standard Python list. Now, just a disclaimer. Now that we know how to use NumPy, let us see code and witness the key advantages of NumPy. That is convenience and speed of computation. In the data science landscape, you'll often work with extremely large data sets, and thus it is important point for you to understand how much computation time and memory you can save using NumPy compared to standard Python list. So let's compare the computation time, the computation times of arrays and lists for a simple task of calculating the element wise product of numbers. Element wise product of numbers. So I'm going to import a library which is known as time, which we very rarely use. So this will calculate the time required for your computation, right? And I'm going to compare the time taken for computation, right? So let us create two lists and uh, let's calculate time required for calculation. So I'm creating I for I in range. Let's say we have 1, 2, 3, 4, 5, 6. 7, 7. 1, 2, 3, 4, 5, 6. Okay. Let's say we have this number, and this will create a list in this range. So now I have two lists, j square for j in range, same range. So 3, 3, 6, 3, 3, 6, and 1, 7. Right? Now I'm going to calculate T0, which is equals to time dot time, open close bracket, product underscore list is equals to list of map lambda x comma y. I'm creating a lambda function which will calculate product of two numbers, comma list underscore 1, comma list underscore 2. And T1 is the time taken for this thing. So list underscore time will be T1 minus T0. T1 minus T0. And I'm going to print this time required for both the subtraction of the time. Let's say T1 is nothing but it's a time required for to perform this first function. It is, let's say, 13 second, 13.07 second. And let's say T0 is 5 seconds. So subtraction we are going to do T1 minus T0. This is just for list, right? This is just for list. Now let's create numpy array. Now let's create numpy array. And let's quickly see the computation time required for numpy array. So I'm going to write np.array, this underscore 1, array underscore 2 is equals to np.array, this underscore 2, e1 is equals to time dot time, and numpy underscore time is equals to t1 minus t0. And I'm going to print this t1 minus t0 again. So in second segment, which is this, here we are going to create an array of that list. So what is your first list? List one is just a number, I for I in range, 1, 2, 3, 4, 5, 6. So it will start from 0 up to 1, 2, 3, 4, 5, 6 up to this number. This is your list one, right? This is your list underscore 1. What about list underscore 2? It is a square of that number. J square means 0 square, 1 square, 2 square, 3 square, 4 square, 5 square, up to that particular number range square. Is this thing clear? What is there in list 1, list 2? Everyone? Now, if I just calculate the time required to get to compute my array 1, and time required to calculate my array, which is array 2. So T1 is this array which is going to convert array into for a list 1. Array 2 is nothing but uh, array 2, it will calculate, and time 1, T1 is the time required to calculate that array. Time required to calculate that array, right? Now, now what we are going to do is we are going to subtract that time again for array itself. Just like your list, we are going to subtract that. And I'm going to take ratio of time taken for both list as well as numpy array. So list underscore time slash slash numpy underscore time. If I run this, it will take some time and will calculate time required for list as well as numpy array. So suppose your subtraction of time required for list is 13 second minus 7 second, which is let's say 6 seconds. And for your array, it is 5 second minus 2 seconds. So it is 3 seconds. So the ratio is 6 divided by 3. It will be 2. So your numpy array is 2 times stronger, 2 times computationally fast, right? So we'll calculate subtraction of time required to calculate list. We'll calculate subtraction of time of computation required to calculate array, and we'll just divide that to calculate to compare list and array, how it is faster. So this is np is not defined. Okay, I need to define that. Import numpy and np. Now this first it will print t1 minus t0 for a list. Second, it will print t1 minus t0 time subtraction for your array. And third, you are going to take up the you are going to take up the time ratio of the time. Let's wait for this output. Now I understand at this point itself. I mean, this is not that difficult, but you'll find it little heavy to digest. But it's very easy. See, here we are creating two lists. This is time. This is a lambda function, which we have seen to calculate the product of two numbers. This is again time. List time is t1 minus t0. We are printing that. Then we are calculating numpy array, right? Array time required for that. We are printing that. So, okay, what has happened is it is 0. It should not be 0. Just a minute. I'll just restart and run all this. It should be in the multiple of 20, at least 15, and more than that. Let me check what is wrong then. List one I've created. Okay. T0 is this, product list is this.
I think you have used floor division.
Sorry.
You have used floor division at the last sentence. List time divided by.
Just a minute. No, that is fine.
NumPy you have to
Floor
define
division
three.
returns the numerator in like a whole number thing, right? Since you are dividing 3 by 6, it's like 0.5, but floor division returns only 0.0, right? So if you take one slash, it should be fine with this.
No, no, that is fine. That is not something which should not be there.
NumPy time should be in the numerator to get like a full value.
0.4. Okay. Hmm. Right. But this is 0.49 means numpy time required for numpy is
I have a doubt actually.
yeah. Yes.
Time returns the current UTC time, right? So if you're calling it again after like T naught minus T1 minus T naught, obviously T1 will have the time elapsed for both the previous listing and the current thing. So
You're talking about which line number?
You just added the new thing. That's the right one.
This one.
Yeah. Now it should work fine, I guess.
Yeah, this was missing all there. Yes. Uh, and if I just restart and run all this, it's not giving us the correct output. It should be 20 at least. Okay, let me do the same thing in collab. What I'll do is I'll take same lines of code in collab itself. I'll just compare the time. Previously, I've run this code. I've taken, taught to other batch. It was coming 20. So it should be 20 at least. 1, 2, 3. 4, 5, 6. Okay, what is this? It is 1.06. What if I just remove 1 0? Let's remove 1 0. 0.855. How this is possible? Two, two, two. Array 1 into array 2 have done that. Okay, I've not done that. Yes, that is something which is missing. Array 1 I have defined. Array 2 I have defined. NumPy array I've done this. After this, I should write down T0 here. Time. It will calculate T0. T0 it will calculate. Then I should do the product of this because we are interested to calculate time required to multiply these two NumPy arrays and list, right? So that is missing. That's why it was not giving us the correct answer. Then T1 is equals to time dot time. NumPy time I have already defined over here. And I'm going to print T1 minus T2 perfect. This will give you the output, which should be at least in the see 23.80. I'll explain this. Okay. So first is list time, right? Second is NumPy time. Means first time is nothing but time required to multiply this to list, and we are doing subtraction of that. Second is time required to multiply the NumPy arrays. So as this is positive and very high number, time required for computation of NumPy list is 75 times time required to calculate NumPy arrays. Yes or no? So can we say like that? Uh, we can say this, no, in this case, NumPy is an order. Excuse me. Excuse me, guys. Yeah, is an order of magnitude faster than list. So this is with arrays of size in millions, no? But if you see the size that we have taken is in million only, right? But if you just in real world scenario, you may work on much larger data, right? On much larger arrays of size. sizes in order of billions. Yes or no? So then the difference might be actually magnified. Then the difference is even bigger or larger, right? Another thing is some reason for such differences in speed are some reasons for such difference in speed are numpy is written in C, which is basically being executed behind the scenes, right? Second, you should know that numpy arrays are more compact than list, meaning that is they make much lesser. Sorry, they should. I shouldn't take. They should. They take much lesser storage space than your list. That's why it is slower. Now, the following link or discussion of the forum I will share. Following discussion demonstrate the differences in speeds of your NumPy and your standard Python, right? So I'll give you two links to read about this, uh, which is an additional part. So there's one website which is known as Stack Overflow, which is very useful if you're interested to uh, get resolution for your doubts or for your errors. Right? I'll just share that just first. Okay. So if you just write down why NumPy arrays are so fast. If you just write down this, why NumPy arrays are so fast. And if you go to Stack Overflow, you will get this link, right? So this should be your first discussion. You should read this, even though this is something which I have discussed just now, but you can have this first link. Second is it's again uh, an- a Stack Overflow link. What are the advantages of arrays of NumPy over regular Python list? And I need to go for Stack Overflow. This one. So what is Stack Overflow? It's a community. It's a website which is being used by uh, industry people who are actually struggling to get an idea about the error that they are making while just developing the code. So they usually follow this website and it's very useful. Uh, this was predominantly used earlier when we guys did not have ChatGPT and LLM models, right? Nowadays we get resolution quickly on ChatGPT and Gemini, but earlier this was very helpful. You can say this was savior of our job, right? You get an answer for which is posted by uh, different people out there who are actually um explaining the errors that we are getting. So as you know, Python has a lot, I mean, community in Python, it's very huge, right? So that's why this is one of the solutions uh, you guys can have for your error part. Right? It's very helpful. So here this answer is posted by this user and asked by this user. Here you'll find this answer is posted by Robert, this guy. So again, it's very useful. You should remember this website, this discussion, right? So that's what we have. That's all we have for NumPy. I'll be sharing one practice exercise with you. You need to solve that. It's very simple. That will be your part of homework today. Practice exercise. I'll be sharing at the end of the day. You just remember. You just notify me at the end of this session. And finally, we are going to have a summary of what are the different topics uh, in NumPy that we have discussed, right? Okay, so the in this session you learn about the most important package for scientific computing, that is uh, your NumPy. The various operations that you learn about include arrays, which are basic, uh, the basic data structure, right? Second, we have discussed how do we create NumPy arrays. Third, we have discussed creating randomly large arrays, which can be done using arrange command. Then we have seen analyzing the shape and dimensions of an array using array, shape, and dimension, right? And so on. Then we have seen indexing, slicing, and subsetting of the array, which is very similar to list, to indexing in list, and working on multi-dimensional array. And then we have seen how to manipulate array. How do you manipulate arrays using reshape, edge stack, V stack, right? Now in the next session, you will dive deep into new library called PANDAS, which is used to manipulate heterogeneous data, right? We'll see that now. And it's always highly recommended to go through the official website of any library out there, official documentation of that, in order to have more sense of any library out there. So suppose if you are really interested to know or learn advanced NumPy, which is not suggested at this point of time, but you can officially, if you can go to the official documentation of NumPy to explore different functionalities in NumPy, right? So that's your last reference for your NumPy library. So this will explain you NumPy in much more details, right? Now let's create new. Okay, let's create new folder. Let's rename this as pandas, and let us create new notebook for today. which is 26th. Well, let us start with the pandas, right? So what is pandas? It's a library specifically for created for data analysis. It is built using NumPy. You'll be using pandas extensively for data manipulation, visualization, building machine learning models, etc. So this is one of the two uh, important libraries which will be your friend for the entire data science journey, right? So that is introduction to Panda. First was your NumPy. You should know that. Second is Panda. It is specifically for data analysis. It is built using NumPy. You will be using pandas extensively for data manipulation, visualization, building machine learning models, etc. Right? Now, uh, it is one of the most used library in Python, and this is because of the powerful data construct that it offers. You'll learn about the data constructs as you move ahead in the session. But let's first initialize the pandas library. To initialize pandas, you can write down import pandas as PD, as simple as that, right? And in this session, we are going to learn about creating data frames. Second is importing CSV data files as pandas data frames. Third is reading and summarizing data frames, then sorting data frames, labeling, indexing, and slicing data, merging data frames using joins, and pivoting and grouping. So this will be our agenda. And let me check quickly what is our today's agenda for which is shared by GUI. Let me check that so that I should not miss anything. Mhm. Okay, I'll just share the entire screen and let's discuss that. So this is totally completed. This is completed. This is also done. Math function is something which we'll discuss now. So session 3 is complete. Session 4, advanced functions and argument list, handling debugging in Python class and objects. This is something which we are going to discuss today. Then we have lambda functions, filters, map, Python, PIP, pickling, JSON, API, web scraping. This is also will be covered in Pandas session and series, and this is querying, loading, merging data frame. This is very basic. That will be covered in today's session. Group by and manipulating data frame, time and data and functionality that will be covered in Pandas. So, in a nutshell, we are going to see Whatever is left with, I mean, whatever is remaining, we are going to see, we are going to cover that in this pandas session, right? So in this session, we'll discuss that. I mean, in not in single session, in your pandas entire sessions, right? Okay. Now, we will just see basics of panda. So pandas has two main data structure. You should know that two main data structures. First one is series. Second one is data frames. The more commonly used data structure are data frames. So most of this session will be focused on data frames. And when you encounter series data structure, I'll explain them briefly to you because that is not something which you guys will be using it moreover. Or I'll tell you frankly, series data structure is very listly. I mean, we use this very rarely, right? So the major focus should be entirely on your data frames, which is very important. So I'll write down over here. So most of this session will be focused on data frames. When you encounter series data structure, I will explain them briefly too. Now let us begin this session by introducing Pandas data frame. So what is data frame? Again, very simple and crisp definition of data frame. It is a table with rows and columns. That's all. With rows having an index each and columns having meaningful names. So there are various ways of creating data frames. For instances, for instance, creating them from dictionary, reading from .txt and .csv files. Let's take a look at them one by one. So you can create data frame from your dictionaries. You can read .txt file, or you can read CSV file, PDF file as well to just convert that into data frame. So let's give heading as creating data frames from dictionaries. If you have data in the form of lists present in Python, then you can create the data frame directly through your dictionaries. We'll see this thing. The key in the dictionary acts as the column name, and the values stored are the entries under the column, right? All right. So That's what we have for the data frame. Now let us understand how do you create data frame first. So we generally import pandas and numpy very first. So only one time is sufficient, but I'm just to give you guys an idea how do we do this. We'll do all imports. I'm going to import numpy as np. I'm going to import pandas as pd. Example one is the question one is I need to create a data frames cars using raw data stored in a dictionary, right? So let us create a dictionary first and let's try to convert that dictionary into a data frame. So cars per capacity, I'm creating a list L09, comma, random numbers 588, comma 18, comma 200, comma 70, comma 45. I'm creating a list again, country. Let's write down United States, Australia, Japan, India, Russia, Morocco, and Egypt. And I'm going to write on rights underscore right equals to true, false, 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 again true, right hand drive true, right, right. All right. Now I'm interested to create a dictionary first. So cars per capacity, which will be cars per capacity. Then I have country, which will be country. And I have drives, let's go right, which will be drives underscore right. If I run this, and if I just check data, so this is my dictionary, right? I've converted by using this list which I've created. Now, how do you create a data frame? So I am interested to create a data frame by using pandas. The function is pd dot data frame. So if you see over here in this function, D is capital. Remember this. And F is also capital. PD is nothing but the pandas library that we have imported. And this is your function, data frame. You'll ask if I don't follow this, what will happen? So I'm just explaining this over here. It will not give us the output because there is no attribute called data frame, which is D small and F small. But if I run this, I'll be getting the output. No error over there. And this is how you convert any data structure into a data frame, which is nothing but in the form of rows and columns. This is rows and columns. Here, what do you have? You have a dictionary. Right? So dictionary is converted in the form of rows and column. That is known as data frame. And this is how you do this. And if you just check data type of this cars, it will give you pandas.core.frame.data frame. So it's a data frame, right? Now you guys quickly can do this. I'll give you 2 minutes and then we'll discuss another example, which is reading data from a file. That can be Excel file or CSV file, right? It's 9:55. I'll give you 5 minutes to do this. So try this out, everyone. Before that, you need to import libraries first. So import your libraries, pandas as PD, numpy as np, and then write down this. Yeah, is it done, everyone? Yes. Okay, all right. So that's what we have. I'll share a file with you on your drive. You just make sure you download that. We are going to use that particular file, right? So on your drive, I'm just uploading one file under the name of day 6, 26th October. Here, the file that will require is cars underscore CSV file. Yeah. So I'm just uploading that file. You quickly download that and let me know if you're done with the downloading part. CSV. Yeah. This is your link. Now again, I'm sharing this link, but make sure you already have that drive link with you so that whenever you want to revise any topic, you can do that easily, right? So I've given that link on your drive. Uh, I've uploaded that. I've shared the link, and I'm going to read that file. So, how do you read a file? See over here. Let's add a heading as um, create a data frame by importing cars data from cars.csv. So the heading is read a file, read a file using pandas. So cars underscore df is equals to pd.read underscore csv and cars.csv and cars underscore df. Okay. Before that, you need to upload that file where you have a current Jupyter notebook which is running. So you wanted to read that file, Excel file or CSV file in this notebook, right? 26th October pandas. So I will make sure that I have file uploaded in the same folder itself, right? That is your first. So I'll upload it quickly over here. You guys also need to upload the file over here only. You will upload it over here. And then the file is having extension. File is CSV, right? It's CSV file. It's a CSV file. So you need to write down pd.read pd.read underscore CSV. If it would have been Excel file, pd.read Excel, you will write. If it is other, if it is a table, you will write pd.read underscore pd.read underscore table. We'll see this thing, different kinds of file and how to handle that, which is known as file handling. But at this point, we only have CSV file. So we'll write down pd.read underscore CSV. That's all. And if I just run this, right? If I run this, I'm gonna get the file in the form of data frame, the Excel file in the form of data frame, and this is what it will look like, right? But if you carefully observe, is this thing in correct format, just check heading of this particular file. Is it correct heading? What do you think, everyone? Is my heading is correct or not?
It is not matching.
So what should we do? I mean, what is your problem? Why it is not correct?
Actually, the heading itself is looking like a data.
Yes, exactly. Very good. So I need to skip that. I need to change that. What I'll do is, this is your example number 3 comes into the picture now, as known as column headers. I would be reading a file to skip the header, to skip the header. So I'm going to create one. You can do it over here as well, here only, but I'll write down again because this is just for your understanding. pd dot cars underscore df is equals to pd dot read underscore csv. I'll tell you a few more ways to copy the file path. You can directly copy this and you can paste it over here in the codes. This is first way. Second way is second shortcut to copy write down path of this. You just remember the initial letters of this file, which is CA, right? So I'll write down CA and I'll press tab button. It will auto complete. It will give you a solution, right? This is another way. So tab is another way. Now I'll write down header is equals to, I don't want header. So header is equals to none. So whatever header will be there, it will be none. So if I just run this, and if I write down cars underscore df, you see we don't have this, right? Now can you guys do this quickly? Read your file first of all like this, and then by using header is equals to none. Do this quickly, everyone. Yeah, is it done? Have you guys loaded that file? Everyone?
Yes.
Okay. So header is equals to none is something which we do to don't have, in order to not have the header, right? This is your first basic thing. Now, second is I need to assign headers because I wanted to give column names to my data frame. Well, it should not be 0, 1, 2, 3, 4. I need to assign that. So I'll write down assign headers to uh, my data frame. I'll write down the heading and returns an array of headers. So I'm interested to check the column names. For that, we have a function which is cars underscore df dot columns. Cars underscore df dot columns. Right? Now I need to rename headers. So what I'll do, cars underscore df dot columns. I'll just take that. I need to assign a column name which is country code, comma region, comma country. Fourth column, I want to rename that as cars per capacity. Fifth column is drive underscore right. Fifth column is cars underscore drive underscore right. Right? Cars underscore df. Now I have just assigned the column name, which is country code, which is region, which is country, right? Then cars per capacity, and then drive right. This is my column name. And I've just assigned that by using cars underscore div dot columns. That's all. So this is how you give column, right? That is another thing. Right? You want to try this? You can write down this quickly.
Not defined.
Yes, is it done, everyone? Is this thing done?
I'm getting cost DF is not defined. I have to mention that.
Class def is not defined. It means you have not defined the data frame under this name, no? Yeah. Okay, can you share your screen quickly?
I'm checking. Can I able to see my screen?
Yeah, yes. PD is not defined. Means you have not imported pandas. Where is the pandas? You run that one more time. Run this. Run Excel, NumPy. Yes, run this now. Right. Is it clear now?
Yeah, got it.
Now cast diff is not defined. Scroll up. Okay. And above, scroll up, scroll up. Here, columns. Spelling is not.
Okay.
Run this, run this, run this. Cast diff dot columns. Yeah, you'll get that. Correct. Is it fine now?
Yeah.
Okay. Excellent. You can stop your screen sharing now.
Okay.
Just a minute. Give me a minute. Okay. Now, what we are interested to do is we we are interested to, yes, suppose here you are indexing. This is known as indexing. This is known as indexing, right? Uh, so uh, here this is my index, right? This is my index. This is known as index. And I don't want that index, it should start with the 0, 1, 2, 3. I want it should start with the column, country code column, right? What I want is, I mean, what generally I want to do is, sometimes I want to analyze my records from the country code itself. I want to analyze my records from the country code itself. So I'm interested to have my index which should start from 0, not starts from here, country code, not from 0, 1, 2, 3, right? So what I'll do is I'm going to uh, read that file one more time. Again, this is not required. You can do it over here as well. But for your understanding, I'm doing it separately, right? So I'm reading file and set first column as index. And I'll copy the same thing, header is equals to null. There's one more thing which is known as index underscore call is equals to 0. And I'm going to read this, right? But here the column name is not defined that we already have done. So we should do that here only. Set the column names cars underscore df. Okay, what is happening? Mismatch. 4 elements. Is it for each? Okay, shoot, right. Country code should not be there because we want that should start with the country code. So here you will have only 4 columns, correct? Now can you see earlier we were having index over here, but I'm giving index from the country code itself. So index underscore call is equals to 0 means it should start with 0 here. Index underscore call equals to 1 means your first column. See, here also, here also your indexing will start from 0. So this is your 0th column. This is your first column. This is your second column. This is your third column. And this is your fourth column, right? This is your 0th column, first column, second column, third column, and fourth column. Is it correct? Is it clear now? So if you write down index underscore call is equals to 0, if you write down index underscore call is equals to 0, so it will start with the 0 column. If you write down index underscore call is equals to 1, it will start with 1 like that. And these are the column names that we have, right? Is this fine now, everyone? Are you guys understanding this? Because from now onwards, things will be little advanced. We are going to move towards the second level. Earlier, we were just having first level, right? Basic. Now, from pandas onwards, second level is started. Level number 2. So if you don't, if it's not clear for you, you can ask right now itself. Otherwise, we'll go to next part. Anybody have any questions now here? Now I need to print the new index by using cars underscore df dot index, which will be this thing, right? USCA is this one, this U, EUR, AFR. These are the index for my data frame. Now the index heading is 0, no? Index heading is 0, but I want to rename that. So how can I do this is, I'll let them rename the index name. I'll write down cars underscore df dot index dot index dot name. Index name, it should not be 0. It should be country code at least for me. So I'll write down cars underscore df to get the output. So it's not 0 now. It's not 0 now. It's not 0. It is country code. This one. It's not 0. It is country code, right? This is how you set the index. And what if you want to delete this? Delete the index name. This again very simple. Cars underscore df dot index dot name. It should be none for me, and I'll write on cars underscore df. So I don't have an index. Index is not there, right? Can you just see this? We don't have index over there now. So that's what we have. You try this out quickly. Set your index underscore call. Do this. Do this and do this. 3. Is it clear, guys? Yes, can I get response in the chat, everyone?
Yes, clear, Vipul.
Okay, excellent. Binu is asking, can we read file in a different path? Different path means, what is your question? Different path. You are trying to ask name, this one. Can we give different name to this?
Yeah, here we have cast.csv, right? If it belongs to a different path, how do we read it? Should we give the entire path in as the first parameter?
Sorry, can you please ask question one more time?
Yeah, in read underscore CSV, that method,
Hmm.
the first parameter is the file name.
Yeah.
Do we have, like, if it belongs, if it is placed in, suppose it is still there in the download folder, can
Hmm.
we have the full path given there and then can cars.csv we read. Like instead of moving it here where the
Hmm.
script is.
No, no, no. There's no any method like that. You have to upload it over here. If you are using your Colab, Jupyter, if you are using Colab, you have to upload it over there as well,
Okay.
right?
Yeah. Okay. Yeah. Thanks.
Okay, try this out, everyone. You don't. You can let me know if you don't want to try right now. We'll go to the next part. But if you want to try, that's not a problem. I'll wait for 2 minutes. Okay, I have one question. How to change header for the third row instead of the first header index? Kannan, can you please unmute and ask the question? Ishwarya is asking if I want to fetch particular data from DF, how can we do that? We'll see that. We'll see that. That is something which we are going to see after some time. But I am not clear with this question, Kannan. What is the question? How to change the header for the third row?
Yeah, so we have that country header, right? So how to change that header?
We have that. Which one?
We have a region, country, car per caps, right? So how to rename that?
This one.
Yeah, below them.
That is something which is there in your uh, file, no? Here.
Okay.
So you can do that, but that is not suggested. Why you want to do that? So see, basically what will happen is this data is very simple, no? Here we have 1, 2, 3, 4, 5, 6, 7, 8, 8 records. But your question, suppose if we have 500 rows and you want to change each and every rows out there, it's not possible, no? You are asking to change the entire data itself. Can you see this? This is your data, which is very simple. What we have done is index underscore call is equals to first 0 will give you the index as your first column. That is your record, this record. And you are asking, your question is to change that ultimately. It's not.
So for that index 0, you have renamed to country code, right?
Sorry.
So in the current screen, so for that country code, you have that header as 0, right? Index of 0.
Index of 0. Okay, here.
Below that region. Yeah, right.
Uh,
So for that 0, you have replaced with country code.
right. But that is heading, no? That is
Yeah,
heading.
yeah. That's what I'm asking. For next heading is region, right? So can we rename that one? So is it possible to rename?
No, no, no. It's not possible. See, this is your column, no? This is your index. What is your index? First column itself, no?
Okay.
This is not your index, no? If you want region as your index, then you can change this index underscore call is equals to 1 because that is the first column,
Okay.
right? This is your index, not this one. No, if you see first page of any book out there, here you have serial number. That is your index, no? Serial number, and here you have title of that particular thing. 1, 2, 3, 4, 5, something like that. This is known as index. This one, right?
Yeah.
That is known as index. Is it clear now?
Yeah. Yes.
Okay, let's go to next part. We'll read file and set first column as index that we have done. That is something which we have done. Okay, now coming towards your question, it's good that you have asked this question. I wanted to explain that as well. See, now you want to make region as your index, right? You want to make region as your index. So for that, you can do very simple thing, which is cars underscore df dot set underscore index. And that is nothing but your region and your country code. And I'm going to write on in plus is equals to true. Now here it's not happening because it's not in the column itself, country code. But what we'll do is we'll read that file again, this file. We'll read this, and we don't want to set index at the first go itself. We'll read this file. Index will not set. This is your file, right? If you check cars underscore df, you have this one, right? Now you are going to set the column names. You are going to set the column names like this. Setting the column names. And I'm going to write down cars underscore df dot set underscore index. In that, now see, I want to give multiple index now. So region and country code should be my index. But the sequence is first index, it should be region, and second, it should be country code. Okay, the column name is not proper. We need to add one column name because in our data, I'll just show you. In our data, we have 1, 2, 3, 4, 5 columns, no? So 1, 2, 3, 4. We need to add one more column over there. That is your country code. Country underscore code. Now, if I do this, and then if I quickly check what is there in cars underscore df, so this is what you have over there. Can you see this quickly? So we have two index and the sequence is something which you want. So region has to be first and country code has to be second. Right? And last but not the least, I'm going to give you one insight about this. I want to write data frame to file. So I'll write down cars underscore df to cars underscore to underscore csv dot csv. And I'll write down cars underscore df dot to underscore csv and cars underscore to underscore csv dot csv. Now, what is this thing? I am interested to save whatever I have done, the analysis that I have done over here, setting index, changing column names, cars underscore df. I'm saving that file under the name of cars underscore to underscore csv, this name. And if you see, I've created one more file. Can you see this? So this analysis that we are generally doing over here, we are just storing that under the CSV file, which is cars underscore to underscore CSV over here. And you are going to get the output for that. So it will be affected over here, right? Suppose you don't want to save that file in CSV, you want to save that under Excel file. So you write down cars underscore df dot to underscore Excel, and you'll write down cars, the name for that file. It should be cars123 dot xlsx. So to underscore Excel will store that file in Excel format. Can you see this now? Here. So this is your name for that analysis for that file, and you're saving that under the Excel file. Is it clear now? Everyone?
Yes, Vipul.
How do you save your analysis? Now you try this out. I need to have 5 minutes break. I'll take that. But you need to try this out. So what was the last thing that you have done? This one. Okay, here uh, set underscore index, do this thing and save this file. I'll give you 5 minutes for this. This one and this one you have to do. So try this out now. Yes, is it done, everyone?
Yes, Vipul.
All right. So now we are going to start with the advanced part from now onwards. Okay.
One,
So
one second, Vipul. Sorry to interrupt. I will quickly do a screen share.
you want to do this now?
Yes, one second. Screen share I will do. I have saved cost to CSV as another file, but I didn't see my changes here.
Okay. Share your screen quickly.
This is the file I saved.
Mhm.
I'm getting bound method and leave screen to CSV like this.
What is the, you just scroll down first of all. Last, yeah. Cars underscore df dot to CSV, cars underscore CSV. And that is your CSV file, no? Why you're checking that? You cannot open it. I mean, bound method. Basically, that's a CSV file, no? You're not converting that into data frame. This is your data frame. Yes. You are just storing whatever you have done in that CSV format. That's all. Yeah.
I'm just replacing this, okay? Set index. I'm just replacing this and try to save. Previously, I got this row as the first index.
But where is your set underscore index? You're not setting that, no? Where is your set underscore index? You're setting index cars underscore per capacity. Oh, you want all as part of your index. What do you mean by set underscore index? You're setting index, and this column should be your index. You're setting all as your index, no?
Oh, okay.
Yes or no? Only select two columns, only two columns for an example. Yeah. Now, this is what have you done is index underscore call is equals to 0. That should not be there first. Remove that. Uh, Now run this. Okay, perfect. Now go to the next line, set your index, and yes, in place is equals to true. You are not writing down, no? In line number 64, after that country code square bracket, after country code square bracket, after square bracket, comma, in place is equals to true. Means whatever changes you are doing, you wanted to in place, PLACE, in place is equals to true. You wanted to do changes permanently, no? That's why you do that in place equals to true. Now you're getting that, right? And then you can save this. Now you can stop your screen sharing. We'll quickly go to next part.
Okay.
So in place equals to true is very important. Remember this. We do this to in order to make changes permanently on your data frame. If you don't do that, it will forget and it will not give you the output for that. And this is example 5, uh, in which you are going to write a data frame to a file like that. Now, okay, now I will share one more file with you on your drive itself. You go and check over there. Day 6, that folder only. I'll share one more file. New folder. I'll upload a file, which is sales.xlsx. Sales dot Hmm. Okay. Can you just check now? Can you just quickly download the file, everyone? This is your link. Download that file. File name is sales.xlsx. Are you up with that file, everyone? Do you have that file with you? Upload it over here now. Download that file and upload sales underscore Excel file over here. Yes. Is it done?
Yes, Vipul.
Okay, you can take your time. I'll just go to next part. You can watch your recording. Now, what I'm going to do is I'm going to have one case study, which will be very important for you. You can literally uh, cover everything, or we can literally discuss every point in pandas by just solving this case study, right? So I'm going to import all the libraries, necessary libraries, importing numpy as np, import pandas as pd, import matplotlib dot pyplot as plt. And what is this? We have sales and profit data in our sales underscore Excel file. So I'm going to give quick heading as reading file, giving name as sales pd.read underscore Excel. The name of the file is sales.xlsx. I'll just check what is there in sales. So this is my data in which I have market, region, number of orders, profit, and sales column. Right now, I want to check shape of this data. I mean, how many rows are there? How many columns are there? So to check shape of the data, we have shape method. So which will give you have 23 rows and 5 columns total. Right? We have one function which is known as head. So head will generally give you first 5 records by default. First 5 records 0, 1, 2, 3, 4. So we have one first 5 rows, right? We have 1, 2, 3, 4, 5, right? If I write down sales underscore sales dot head 3, I'll get 3. If I write 4, I'll get 4 record, first 4 records. And if I don't write anything, I'll get by default 5 records. Similarly, you have tell method, which will give you last 5 records. So if I write down sales dot tell, which will give me the last 5 records. So what are the last 5 records do you have? You have this 18, 19, 20, 21, 22. So these are the last 5 records in your data. Right? This is your last 5 records by using your tell. Now I'm reading a file and setting first two columns as index, which we already have discussed how to set that, but let's do that. Sales equals to pd dot read underscore Excel. As this is your Excel file, so we are going to write down pd dot read underscore Excel, right? And quickly write down the name of that file, create a tab, write down index underscore call. It should be 0 as well as 1. So what is your zeroth column? Market is your zeroth column. What is the first column? Region is your first column. Yes or no? So you are going to set that index underscore call and you are going to write down sales over there. So market and region will be your index, and the sequence is 0. 0 is your first index will be market and second index will be region. So that's what we have for this, right? And for this as well, now for this data frame sales, now it is having two index, market and region. I'm going to write down sales dot head, and which will give me first 5 records, and I'm going to write down sales dot tail, which will give me last 5 records, right? Now, do you guys have any questions?
I could see that from the index, there was only distinct values are getting picked.
Sorry.
The first column, that is market, earlier it was every row had data.
Mhm.
Now we can see only Africa like that, like only one data is being used.
Not only one data, no, you have Africa, Asia Pacific, you have Europe, LATM, USCA. As you are doing head, so you'll get first 5 records, no, only.
Okay, but it is like not every row is having Africa, right? It is something like a grouping that is happening.
Obviously, not every column is from Africa, no. See, you have first 5 records which are from Africa, second is Asia Pacific, then
Okay.
you have Europe, then you have Latin America, USCA, Western US, right?
Yeah,
Yes,
yes,
Vipul.
yes, Vipul. But the while displaying the data, it seems like it's grouped, right? That's what she's asking. I think this one.
It's group, yes, it's group. Why? Because uh,
Mm.
your index is market, no, first. Your
Yes, yes.
market. So for all the markets out there, it can give you the same thing, no?
Yeah,
Africa.
yeah, 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 yeah.
But that is not
So that for the displaying purpose, it's omitting the duplicate one, right?
no duplicate. It's not just a minute. See,
Mm.
uh, how many records do we have for Africa? Let's calculate that.
Okay.
How many records do we have?
I think 5 records.
5. So
Mm.
in the output itself, we have 5, no?
Five.
So it's not removing duplicates.
Yeah. That's we don't have any question, Vipul.
It's just like
Mm.
instead of giving all the headings as Africa, it has given
Mm.
under the group. That's all. That's what.
Okay, fine. Mm.
This is something which is known as grouping by, which is again very important part, which has a separate function, group by. We'll see that after
Mm.
some time.
Okay.
Using by using group by as well, you can do this. But here we are just adding an index, no? So
Yes. Okay. Thank you.
all right. Now I want to display only first 3 records by using this. And I want to display only last 3 records by using this. Right? Now example number 2. Display the information about the data stored in data frame. So I'll return sales.info. Sales.info. Info is a function which we use to get the information about the data, in which we get total number of rows, column names, their data types, and how many null records do we have. What do you mean by null records? So in the last file, if you see, for the last column, we had a null record. This is known as null record, meaning that you don't have a value present over there. So it's a blank record, right? And this NaN, it means not a number. NaN means not a number. This NaN means not a number. So it is not a number, right? If you just go and check your data here, cars underscore CSV, you don't have a value present over there. It's a blank, right? Can you see this? It is known as null record, right? Now, here as well, we have 23 rows, and for all the 23 rows, we have non-null values, meaning that you don't have any null values in that data set. So this is your data. If you just check it physically, it will not open. But if you just open it in Excel, you'll understand that you don't have blank records over there. I'll just show you. I'll just share that Excel file with you. So that is known as null values. Just a minute, sales. Yeah, I'll just open that. Can you see in this file, you don't have any blank records?
Yes, Vipul.
So that's what it is, right? Here, uh, uh, if you just check, that's what it is. Like we have 23 non-null records. If we have a null records, then it will give you 22 non-null. And from that, you can easily find out how many null values are there. Suppose uh, total we have 23 rows. And in that 23 rows, suppose it could have been like this 20, 21, 20 non-null, 21 non-null. So you have 3 null values and 2 null values, right? So likewise, you can also find, but to find null values, we have a separate function. We'll see that. So this is how you get this. And what is null value? How do you remove that null value? What are the different problems associated with that null values? This is entire a separate part, separate topic, which is again very, very important part, which we'll discuss after some time, not in this session. So today's agenda is only basic of Pandas. In the next session onwards, or most probably next session or next to that, we are going to discuss why generally we have missing values, which we call it as null values in your records, in your data, right? So what are the different reasons that might be the case for your null values, right? Now, next is how do you display the statistical information about the data in your data frame? How do you display the statistical information about your data in your data frame? So we have one function which is known as describe, sales.describe. Right? Describe will give you descriptive statistics. So you are going to get count, mean, standard deviation, minimum 25%, 50%, 75%, maximum values of all the columns out there. And to be more precise, in your data frame, you can only find, uh, you can only get descriptive statistics of your numerical values only, right? So number of orders, profit and sales. That's the reason we have given index as index for your categorical column, your text column. So whenever your column is text, that is known as categorical column. Remember this. And whenever your column is number, that is known as continuous or numerical. Continuous column. Right? So describe will give you output for only continuous column, number of orders, profit and sales. Even though if this is not your index, it will not give you the output for, because we cannot find mean of Africa. Can we find that? We cannot find median of Africa, right? Because it's a text column, string type of column, categorical column. But for any numerical column out there, you can find mean, median, mode, standard deviation, minimum, 25%, 50%, 75%, and maximum values of that records. So that's what we have over here, right? And there's one more thing which is known as box plot, which more specifically we are going to discuss in tomorrow's session. But how do you plot that? Suppose I want to plot box plot for sales and profit dot plot. Kind is equals to, I'll write on box. This is something which is there in data visualization, guys, but I am just giving you guys an idea about that. Just a small trailer. This thing is known as data visualization using Python. We have a separate module for that. Data visualization. All right. So we have plotted box plot. This graph or this figure that is there is known as box plot. We use it for in order to get an idea about the outliers. Now I'm not giving any focus on this because I wanted to explain this separately. At least we need to have 30 minutes to discuss this entire topic. So anyway, tomorrow from the beginning itself, we are going to discuss outlier and box plot and its importance, right? So just an introduction about this. This is how you plot the box plot. Uh, and if you want to analyze a single column, let's say I want to analyze profit column, I will do this by doing this. Or let's say I want to analyze multiple columns. If you're analyzing only single column, then you need to have only single square bracket. If you want to analyze multiple columns in your data, you need to have double square bracket for multiple columns. Double square bracket, right? So remember, most of the times, even I used to get confused initially in my initial learning days, like how to remember uh, when to use double square bracket, when to use square bracket, when to use round bracket. How do we remember this? So I'll give you one very simple hack. See, first point is whenever you're dealing with data frame, any kind of data frame, whenever you're dealing with data frame, uh, we use a square bracket, right? So every time if you see a data frame, and then immediately after that, here we have not started that. But let's say for that particular data frame, I want to select a column, which is profit. I'll use square bracket. For this data frame, for profit column, now I want to find maximum. So what is maximum? Maximum is an attribute or a function. So when you use round bracket, second point, when should you use? Whenever you want to use a function or an attribute associated with any data structure, we use round bracket. So length is a function. So we used to use round bracket. Range was one of the function. So we used to have round bracket. Print, right? Head is your function. Attribute. Tell was your function. So we are using round bracket for that. And double square bracket is something which we use to select multiple columns from a data frame. So if I don't use double square bracket over here, I'll not get the output. It will throw the error over there because it's a key error. You cannot select multiple columns by just using a single square bracket. You have to use a double square bracket for that, right? So that's what we have for the basic part. I'll quickly upload this notebooks on your drive, these two notebooks and the one which we have done to compare competition times in NumPy and standard Python list. And we'll stop here for the day. If you have any questions, you can ask. Otherwise, we'll just stop here. So anybody have any questions now? Yes. Anybody have any questions, doubts in this?
So, Vipul, so using the pandas, we can only plot the data grid and everything like that, or we can do any other stuffs using that one.
We can do only what?
Only the data grid display. Right now we are displaying indexing like that, right? So apart from that, what are the things we can do?
See, pandas can be used to manipulate your data, no? To analyze your data by putting any number of conditions. That
Okay.
that is something which we are
Okay.
learning, no?
So in the next part, we will look on cleaning the data and everything like that, right?
Yes, that is
Okay.
remaining. See, I told you indexing and slide. I told you in the beginning, no, for panda session, what are the different topics that.
Yes. Yes.
So that is remaining, no? This is just a start to this panda.
So far what you have explained, we don't have any queries.
Yeah, sure.
Yeah.
So importing CSV file, reading and summarizing data frame, but sorting, labeling, merging, and pivoting and grouping, that is remaining.
Okay.
Just upload the files on your drive. Yeah, you need a data set as well, but I think I can. Yes. Okay, I've given everything on your drive. You just check under this folder, day 6. And if this last, I told you guys, right? Last 30 minutes is strictly for candidates' doubt and discussion. So they have suggested us to not cover anything theoretically or practically in the last 30 minutes. So that's why we'll stop here for the day. If you don't want to discuss anything, if you don't have any questions, doubts, we'll stop here. Yeah. Arun, Binu, Chandramohan, Darshini, Gopi, Shwarya, Janani, Karthik, Madhu, Murali, Navin, Prashant, Prasita, Sharmila, Shrikaran, we are Karthik, Vijay Kumar. You guys have any doubts? Please share the worksheet which you created today. Worksheet,
Earlier I was trying to
yeah, go ahead.
I was trying to save the indexed data frame into another CSV file. For me, the changes weren't getting reflected in the CSV file, but in the Excel file, the changes were reflected. Is that a thing, or am I making some mistake?
Can you share your screen and ask the question?
Okay.
Yeah. What's your question?
Yeah, sure. I was trying to save the indexed data frame to this file, CSV file. But the changes weren't reflected in the CSV file, but when I saved it in a Excel file, the changes were reflected. So is that a thing, or am I making some mistake here?
What is the file name? It's index underscore car, no? So you should read that file, no? Index underscore car.
Yeah, I read it below.
Yeah, and scroll up. Okay. Index underscore cars. You check is it save in your file or not? First of all, go to your home tab of Jupyter Notebook. Index underscore car.csv. Check that. What is there? Open that. I think it will not. Okay. Yeah. So what is your question now? Go to the.
Region and the country code should be the index, right? But I'm still getting the.
See, in your Excel file, it will not be indexed, no? How, I mean,
In my index file, the changes are getting reflected. I can see those two columns being the index, but not in the CSV file. So,
what I'm saying, no, in CSV file, how you can identify that as index?
okay, that's what I was asking. Will it be reflected?
In your CSV file, assume this is as part of your index, but how you will distinguish it? I mean, how your Excel file will show you that as an index? Yes or no?
Yeah.
In
Okay,
just it's just a highlighted key bold word. That's all. If you try to open this in your Excel, just open this in your Excel. Is it
yeah, it is getting reflected in the Excel file.
right? In Excel, you'll have that as a bold format, no?
Yeah.
Not that, not that. Yeah, this one. Yes. Yes, yes, yes. Can you see this? This is known as indexing. That's all. That's it's nothing different.
Okay. Thank you for clarifying.
Yes, thank you. Um, Prashant, today you don't have any quiz because I have not got any response from them. So probably you will not be having any quiz. I'll upload a practice exercise on your drive. You just check that by the end of the day, or more probably, most probably it will be there on your drive. If it's not there today, I'll upload it in tomorrow's session. Right? So today you don't have any quiz. All right, then we'll stop here for the day. Thank you, everyone, and happy learning.
Thank you, Vipul.
Thank you, Vipul. Thank you.
Thanks, for
Thank you, sir.
Just please don't leave. I got their message. You guys have quiz. Just a minute. I'm just getting call from them only.
Yeah, hi Vipul.
Yes, it's done. You can start.
Sure. So hi everyone. We'll start. Okay. Rules are same. You don't have to look into my screen. You have to look into your own screen. I'll be just pasting the link. Please join. So we'll start it soon. One more minute. Rest. Please join. So we'll start. So now we are going to start the quiz. First question on your screen. What is a lambda function in Python? What does the filter function do in Python? What is the Python pip? PIP. Nice. How do you install a package using PIP? What is an iterator in Python? What is pickling in Python? Which Python module is used to work with JSON data? What is an API in the context of Python programming? Second last question for the day. Which library in Python is commonly used for web scraping? No, last question for the day. What does the request library do in Python? Yeah. Thank you everyone for joining. We are done for today's quiz. Karthik Srinivas is first, then Anbu C is second, and Mr. Sudhar is third. Thank you everyone. We'll meet tomorrow. Thank you, people, for your time. Vipul, are you there?
Yeah, yes.
Yeah, yeah. Thank you, Vipul. We are done for the day.
Okay, thank you.